The next topic is single period inventory model. The models that we have discussed so far assume that it is an ongoing business and the demand will be ongoing. And so you order a certain quantity, and when that quantity is exhausted, then you buy another batch of that product, and then you keep going. But there are instances when the demand may exist only for one single period, and that's it. This is usually the case when you have a product related to an event merchandise. So once the event is over, then the merchandise is no longer demanded. Example, you have special events like Riverbend. So 2014 Riverbend, and you have pins for 2014 Riverbend that you make, you sell that, and once the event is over, then that pin is no longer needed, and if you have excess pins, then it goes waste. Now, the same situation would be true if you have a perishable product. So if you have vegetables or fruits or other products that have an expiration date beyond which it cannot be sold, then once you stock for a particular period, a week or a day or 2 days or whatever it may be, unsold products will have to be either completely thrown away or you have to salvage it, maybe recover some of the cost back. Now, in such instances, the only decision that we have to worry about is how much to stock. So there is no economic order quantity or reorder point or anything like that. So how much to stock? And we can determine how much to stock using this formula, where you have an average expected demand plus Z times the standard deviation of demand, where Z is determined from the normal distribution table for a particular service level. So if you establish a service level that we want to be able to meet 90% of the demand or 80% of the demand, then you use the Z value for that 80% or 90%. But there is a way of finding the optimum service level, and that is given by this formula, C sub S over C sub S plus C sub O, where C sub S is the cost of stock out or cost of shortage if you don't have enough. So if you don't have enough products and there is demand, then that cost would be the profit that we could have made. So C sub S is the sales price per unit minus cost of stocking the unit. So that's the profit that we could have made that we are not able to make now because we have run out of stock. So that is cost of stock out. Now there is another cost, which is cost of overstocking, and we call that cost of overage, and that would be cost of acquiring the product, and now when it remains unsold, then any cost that we can recover, that would be the salvage value. So cost of stocking minus the salvage value will give you the cost of overage. If the product cannot be salvaged, it has to be thrown away, then of course salvage value will be 0. Then you find this service level, and using this service level, then we can get the Z value and insert it into that formula that we just looked at. So let's look at a numerical example. One more example for the single period inventory is newspapers or magazines. Well, if the newspaper that's available today, today's newspaper has demand only today, that's it. Tomorrow there is no demand. And in this example, suppose we have an average expected demand of 120 papers per day with a standard deviation of 15, maybe a small town or something. Now, cost of shortage is, suppose we can sell the paper for $1.25 and the cost to print the paper is 70 cents. So this is the profit margin that we could have made if we had not run out of stock. Now, cost of overage is, suppose if unsold papers can be recycled for 30 cents a paper, then 70 cents minus 30 cents will give you 40 cents as the cost of overage. Now find the ratio using this formula, and that gives you 0.579 as the service level, optimum service level. Now we have to now get the Z value for that 0.579 and plug it into the formula. So Z is approximately 0.2. So 120 copies is the value for mu. Z times standard deviation gives you the stocking level. If you go 1 minus the service level that we found, the optimum service level, so that will give you the probability of stock out or stock out risk.